back again for some more pH work today. Now, with this pH work, this is probably the more complicated side of it, when we're going to do a little more calculations, not just to determine pH or pOH, but to actually figure out the concentration of those ions in solution. So let's flip back a little bit, and let's remember our formulas that we have here from page 7. So page 7 tells us if we're trying to find that H3O plus, the hydronium ion, and remember H3O plus, that's the same as H plus solution, or sorry, H plus concentration. To find that, it's 10 raised to the negative pH. And if we're asked to find our hydroxide ion concentration, remember that's 10 to the negative pOH. So let's try some on page 7 and 8. So number 7 on page 8 asks us, what is the pH? Sorry, not what is the pH. I can't read today. It asks, what is the hydroxide ion concentration if our pOH is 5.32? Okay, so we know that in order to find our concentration of the hydroxide ion, it's just 10 raised to the negative pOH. So, okay, in this problem, we're given the pOH. So in this case, all we have to do is plug in 10 to the negative pOH, so 10 to the negative 5.32. So that's what we'd want to put into our calculator. And then we might be asking ourselves, well, how many sig figs is that going to have? Well, remember, actually, now that I think about it, my answer key is wrong. I'll need to fix it. Remember, with pH, our sig figs are the decimal places. So if we have 2 decimals, you can see it. I don't like that example at the top, but 2 decimals will be 2 sig figs. So after putting it into our calculator, we'd get a concentration of 4.8 times 10 to the negative 6th, and then don't forget that capital M, molar for concentration. Okay, so that one's not so bad. Want to find the concentration of the ion, you're given the corresponding pOH, just plug it in. Let's take a look at number 8 though. Number 8 asks, what is the H3O plus concentration? What is the hydronium ion concentration if our pOH is 3.0? Okay, so again, let's remember, if we want to find our hydronium concentration, to calculate it, it's just 10 to the negative pH. So, okay, we go to ourselves. Oh, easy, right? We're just going to plug in -3. But wait, that's pOH. So we have to ask ourselves, how can we get pH? What's something that relates pH and pOH? Oh, look here. Here's that real important formula. pH plus pOH equals 14. So guess what we can do? We can plug in and solve. Because again, we want the pH plugged in. So we know pH plus that pOH of 3.00 is going to equal 14. I don't know why I made it 0.00, but I did. And with some simple subtraction, we know that our pOH is 11.00. So now what we can do is plug that in. So now to get that hydronium concentration, 10 to the negative 11. We should probably put that into our calculator. We get, my key is so wrong here, 2 sig figs, again 2 decimals, so 1.0 times 10 to the negative 11th molar. And that is our answer. So not too bad, right? All right. Let me give you a little more help now with the rest of page 9 here. Let's take a look at this table. So on this table, you can see all the different values we're going to be asked to calculate. pH, the H3O plus, the pOH, the OH minus, and then finally, we have an acid or base. So I kind of just like to go through this piecemeal. Take a look at what we're given, figure out what we can find. All right, so the first thing we have here in number 1 is we're told our pH is 3.78 And then we're asked to find the hydronium ion concentration. Okay, so maybe just a little reminder here. Our H3O plus is just done by doing 10 to the negative pH. Well, look what we're given here. We're given our pH. So I'm going to go 10 up to the negative 3.78. And again, I'm only going to worry about 2 sig figs on this because there's just 2 there. So 1.7 times 10 to the negative 5th, negative 4th molar. All right, easy, right? Next up, pOH. Okay, we know there's 2 ways to find pOH. We can take the negative log of our concentration. And we also have pH and pOH adding up to 14. So in this case, we're given the pH. So, guess what? We're just going to subtract. 14 minus 3.78. I get my pOH of 10.22. And then just to finish this one, OH minus, remember to get our concentration, just 10 to the negative pOH. Look what we have. So 10 up to the negative 10.22. 2 sig figs. And our concentration is 6.0 times 10 to the negative 11th molar. Then the final question is it an acid or a base? A couple ways we could answer that. I'm going to go to my pOH, not pOH, my pH. That's the easiest for me to keep straight. pH is under 7, so it's an acid. Another way to answer that is to compare H plus versus OH minus. If we have more H plus, it's an acid. Way more H plus, 10 to the negative 4 is like 10 to the 7 times more than 10 to the negative 11. All right, let's do another one. Let's look at number 2. So number 2, we're given H plus to start. So again, I would probably start thinking, oh, H plus, pH is my easiest one to get. Remember, pH is found by taking the negative log of that H plus or H3O plus concentration. So into my calculator, I'm just going to go negative log 3.9 times 10 to the negative 4. And I get my answer of my answer key's so wrong. 3 sig figs, so I should probably have 3 decimals there if I want to be technical about it. So 3.409 would be my correct pH. Then to my next one, pOH. Okay, 14 plus pH equals, no, pH plus pOH equals 14. So 14 minus that 3.409. And my pOH is just 10.591. Because again, pH plus pOH got to add up to 14, so I just plug that number in. And then finally, my OH minus concentration, my hydroxide concentration. Remember, that's 10 to the negative pOH. So 10 up to the negative 10.591. And I get 2.56 times 10 to the negative 11th molar. And finally, is this an acid or a base? Well, okay, a couple ways we could look at it. pH less than 7. Again, I think that's the easiest, is just to look at our pH scale. So that is an acid. Good luck with the rest of page 9. Don't forget, you can always email with questions, and also ask your teachers or check back for some YouTube live hours later in the day.